So Pythagoras and trigonometry, weight, work and power, all kind of rolled into one, if you like. So a car has a mass of 600 kilograms. And so this is the car. I've put it as just a point, basically. Pulled down by gravity. It has a mass of 600 kilograms. But, of course, with mass, we can turn that into a weight or a force by multiplying mass times gravity. So weight is mass times gravity. Somebody is pushing it in this direction. So this is forward. So they're stood sort of behind the car, pushing this way, and they're pushing with a force of 500 newtons. And the question's saying, like, this is similar to an exam question, but there's a few extra bits put in to tie in, work done and power. So if you remember from the last Zoom, we did a similar question. But the first part is calculate the resultant force on the car. It's pushed as it's pushed. So it's got a force this way by the pushing, but it's got a force downwards from gravity as well. So the combination of the left force, as we look at it, and the down force will be a diagonal force. So we'll work that out. Calculate the angle that force makes, the resultant force makes with the horizontal. So it'll be a little angle up here. Then the car is pushed with that steady force, the pushing force, to the left as we see it. It's pushed with that force for 50 meters. Calculate the work done. So work done's force times distance, of course. And then it took 2 minutes to push the car 50 meters. Calculate the power. And power is work done over time, when time is in seconds. So we'll just do the first bit first. So the resultant force. So we've got 600 kilograms is the mass of the car, but we need to find the weight of the car, the force. I'll just make that pen a bit bigger. So we know, so the weight equals the mass times gravity, which is equal to the mass of 600 kilograms times gravity, 9.8 meters per second squared. Get the calculator up. So we do 600 kilograms times, I'll just admit someone, 600 kilograms times 9.8 meters per second squared. 5880 is the number. But what are the units of this number? Because it's a weight. Well done, newtons, which we can put as capital N. So the force, we know the mass, but the force down is 5880, and we know the force being pushed is 500 newtons directly in that to the left, which is like from behind the car. We're looking at it from the side, if you like. So the resultant force, we use Pythagoras. That didn't work. Normally I can do a nice straight line with a tool, but I'll do it as straight as I can. So this is our car. We've got 500 in that direction. We've got 5,880 in that direction in newtons. Obviously, if I'd drawn it to scale, this line would be a lot bigger. So we've got a left push, well, pushing the car forward in that direction. So that direction's like forward because we're looking at it from the side. And then we've got a down weight, and the resultant is going to be left and down. So that's the resultant force. Think of it as a right angle triangle. This height here, the dashed line, is the same height as this line. So this is also 5880. So we've got one side of a right angle triangle. There's a right angle triangle there because that's directly forward. This is directly down. We've got a smaller side and a smaller side, and we've got a hypotenuse. So to work out the hypotenuse, which is the resultant, we do hypotenuse, or can anyone tell me the formula to use for finding a hypotenuse when you know the other two sides? It's the square root, well done by the way, of 500 squared plus 5880 squared. So I'll put that in my calculator. I can do it in one step. So that number is 5880, even though it's a bit obscured. I can do square root of 500, then press x squared to get it squared, plus 5880, and then square that. It's 5901.22. So if it asked for two decimal places, you've got a 2 and a 2. There's nothing on after the 2. If there was a 5 or a 6 or 7 or 8 or 9, and you were told to do it to two decimal places, if this was, say, a 5, then to two decimal places it would be 0.23. But because that is 4 or less, as in it's a 0, to two decimal places it'll just have the two 2's there. 5901.22. So the resultant force, and don't forget, hang on, what have I put there? Have I missed the number out? 5901.22. I've put my decimal point in the wrong place. So 590, that's meant to be a big 1. I'll write it again. 5901.22 newtons. That's how long this line is. 5901.22 newtons. So that's that done. What we needed to do was convert the mass of the car into a force downwards. And then we say what we call resolving forces. We resolve the forces. So we realised that a left push and a down push by gravity are at right angles. So we've got a right angle triangle. Then we use Pythagoras to find the hypotenuse using C equals the square root of a squared plus b squared. Calculate the angle that the resultant force makes with the horizontal. Okay, well this is the horizontal, obviously going across like that. This force here is horizontal. So there's the horizontal is 500. The force down is 5880, and the resultant 5901.22, and it's asking for this angle because it's asking for the angle that the resultant makes with the horizontal. So it's this angle here. You can call it A or call it theta. I usually call them theta, but it doesn't really matter what you call it. So we've got another side here, of course, which is the same height as that, 5880. So to find this angle, we could use sine, cos, or tan, because we know all three sides of the triangle. Technically, I could do it with all three. So if I used the sine, then theta is sine to the -1. Whenever you're finding an angle, you always use the shift key on your calculator and then the sine, tan, or cos. It's always the inverse function to find an angle. So it's sine to the -1 of opposite over hypotenuse from SOHCAHTOA, because you've got sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So it's sine to the -1 of which side is opposite this angle. What's the value opposite? That's right, 5880, and the hypotenuse is 5901.22. I'm going to do shift and then sine 5880 divided by 5901.22. Make sure that your calculator is in degrees mode. If it's in radians mode, you need to change it. Otherwise, your answer will come out in radians. and that is 85.1. If it asks for 2 decimal places, which you'd be told what accuracy you need, 2 decimal places would be what? What would it be if this was rounded to 2 decimal places? Absolutely, yeah, because the 9 pushes the 3 up, 85.14. I'm just going to make a note of it here because I want to put the other ones, cos and tan, on as well. So wasn't too bad. We just need to remember the formulae. We can say theta. We'll do a different colour. Theta is also equal to cos to the minus 1 of adjacent over hypotenuse, which is cos to the minus 1 of which side is adjacent to the angle, please? 500, that's right. 500 over hypotenuse 5901.22. And if we get a different answer, I'll be very surprised. So to get cos to the minus 1, you do shift cos, then 500. Over means divide, so we press divide. 5901.22, close bracket, to be sure. Same angle. So we get the same angle with cos, and we can do it with tan as well. We can only do it with all 3 because we know all 3 sides. If you only know 2 sides, then you have to choose either sine, cos, or tan, depending on which 2 sides you have. But we're lucky here, we can do it 3 ways. So tan to the minus 1 of opposite over adjacent, which is tan to the minus 1 of opposite, which is 580, adjacent is 500. Get the calculator up. So we need to do shift tan to get an angle. Always press shift if you're working out an angle with trig, and it's 5880 divided by 500, and it's the same angle. So we get the same with sine, tan and cos, just to prove that they all work depending on which angles you have. So I'll make a note on paper of that angle, 85.14. The car is pushed with the steady force for 50 meters. Calculate the work done. We've got 2 forces here. We've got the force of gravity and the force of pushing. Which of those forces does work? Yeah, just the pushing, because gravity would only do work if the car was falling downwards or going down a hill as well. So work done is only the distance in the direction of the force that you're on about. And because the car only moves in this direction, it doesn't move down at all, even though there's another force on it. The force that we use for work is the one that makes it move in the direction that you're talking about. So work done equals force times distance, which is equal to the force pushing it, 500, times 50 meters. Have I done anything wrong there? It's not a trick question, just asking if you would you agree with me? Yeah, seems to be. Well, 5 times 5 is 25, and there's 3 zeros. Or if you want to check, of course, on a calculator, 500 newtons times 50 meters, 25,000. Now, what are the units of work or energy transfer? Technically, it'd be Newton meters, because that's a force. We tend to say joules because it's in J for energy transfer. So it's newtons times meters. So it's Newton meters, or you can say joules. You can pretty much use either. It took 2 minutes to push the car. Calculate the power. What's the formula for power, please? If you're too It's a thanks for having this go. It's the work done compared to how long it took. So work done over time, but at least you're having a stab. So thanks. Just read through the formula sheet that I posted recently, which has got these in. So power is the rate at which work is done, and rate implies a time, how quickly. So the work done was 25,000 joules or Newton meters divided by time, but time has to be in seconds. You wouldn't get it given in minutes, but I put it in just to get you thinking. 2 minutes, we all know, is 2 times 60, 120 seconds. So the time it took is 120 seconds. So we do 25,000 divided by 120. 25,000 divided by 120. 208.3 recurring. So to 2 decimal places, it would be 0.33. And what are the units of power? You need to double check the equation formula sheet that I've given out. So it's watts. So we've worked out the weight of a mass. We worked out a resultant force using Pythagoras. We've worked out an angle using trigonometry, as in inverse trig, by pressing the shift key. We've done work is force times distance in the direction of the force, and we've done power is work done over time. So this is a mix-up of a few questions. And if you can do this, then you can get yourselves, it's going to be several marks for all of these together. You're looking at about 10 marks, I'd say, roughly. You need to remember most of them. The one for resistivity, if that comes up, you'll be given that one, R equals rho L over A. You'll be given that. You'd be given the tension and sag formula, which is tension is WL squared over 8S, where S is the sag. But for things like work is force times distance, and to work out a cross-sectional area, you need to learn those. So the ones that I've put on the formula sheet are certainly worth knowing. But the resistivity one you would get given, and the tension in the cable you would get given as well. What you'll find recently posted on Google Classroom, worked examples documents that I've posted. I've put several videos, including last week's Zoom session, which included this as well. So if you look in the shared folder, which is linked on Classroom, called like our folder, everything's in there, videos, worked examples. And on the Google Classroom stream, I've posted various documents, which is me showing you what the answers are to these questions. So it's all there. You just need to, so people, not just yourself, everyone needs to click on and read it, and then you'll see how much is there. But efficiency in life, they say you get out what you put in, but sadly, it's not true, because you never get out the same amount as you put in, because every system has losses. No matter what it is, you never get the same out as what you put in. So what you get out is always less than what you put in. So you never get out what you put in with machines. All machines have losses, and they're not 100% efficient in converting energy. Car engines heat up, And the purpose of a car engine isn't to warm you up, it's to get you moving. So any heat in an engine is wasted. Gears and chains on bikes grinding against each other, that friction causes heat, that's wasted energy. Axles rubbing on bearings and tyres rubbing against the road is friction and heat. It's all wasted energy, so you never get out what you put in. So that's worth remembering. Efficiency, by its definition, is what you get out compared to what you put in. Yeah, efficiency is what you get out compared to what you put in. Compared implies a fraction. Out divided by in is efficiency. A lot of the time we want to talk about percentage because people get scared about comparing a number with 1. They want to compare it with 100 for some reason. So efficiency is always going to be 0 point something. It's not going to be 1. It's going to be less than 1, 0 point something. But efficiency as a percentage will always be less than 100. So percent means divide by 100. So we need to multiply by 100 to make it fair. So efficiency as a percentage is what you get out compared to what you put in times 100. And what you actually get out is what you put in, take away what you lost. Think about it in life. If you're putting in some effort, but some of the effort is lost, then what you get out is less than what you put in. So what you get out is your input effort, take away any losses. That's what you get out, is what you put in, take away the losses. So the output is what you put in, take away what you lose. And of course, the input is just what you put in. So this formula is important for efficiency. Think of it as out over in times 100 as a percentage. And what out actually is, what you get out, is what you put in, take away what you lose. So I would say this is important. The power input to a gas turbine is 28 kilowatts. The losses in the turbine are 1 kilowatt. Calculate the percentage efficiency of the turbine given the answer to 3 significant figures. And there's 4 marks for this, so it's a gift really, in my opinion, compared to some other questions. These are 4 marks that I hope you all should get. So we've got input, we've got losses, so we know what our output is. Efficiency as a percentage is your input, which is 28, take away your losses, which is 1, divided by your input, which is 28. 28 minus 1 divided by 28 is 27 divided by 28. And when you multiply that by 100, it gives you a percentage. But be really careful here. On a calculator, because of BODMAS, if you type in 28, take away 1 divided by 28, what it actually works out, if you don't use brackets and you do 28 take away 1 over 28, what your calculator will do is say 28 take away 1/28th, which is completely wrong. So you have to put your numerator in a bracket to stop this from happening. Then it'll put everything over 28, which is what we want. So make sure you put this in a bracket. And the keystrokes on your calculator will be open bracket 28 minus 1, which is the input, take away the losses. So from there to there is your output. Close brackets, divided by 28. So to divide it by 28, you do divide by 28. To find a percentage, you do times 100, and it's an efficiency. It has no units because it's power divided by power, which is, watts per watts is 1. It has no units. It's just a measure compared as a percentage. So that's how you work out efficiency. And you'll probably want to watch over this bit of the video again, but I've shown you how to, but I would tell the person what you're doing. So I would say 96.4, I would say percent, just to be to make sure, because if you only put, it's a tough one. If they're asking for a percentage and you're giving them this as your answer, then technically it's right. But really what 96.4% is that. So this sign does make a difference when you think about it. So, yes, put the percentage sign in rather than not. That's what I would advise. Good question. Let's have a look at this one. So we've got a graph given to us. We've got voltage, or potential difference is voltage, on the y-axis, and we've got current on the x-axis. And we know that resistance is voltage divided by current from Ohm's law, because V equals I times R. So R, if we're trying to find out resistance, is V over I. So the voltage divided by the current is resistance. And voltage divided by current is the gradient of our graph. Voltage divided by current is the gradient. And the gradient is resistance. Determine the resistance. Well, at any point along here, you can find a value for voltage. You can choose any, but why not make one that's easy? Like where it crosses a line there, the lines coincide and it comes straight down. That's a nice easy one. So the resistance is equal to the voltage at this point, which is, if you come across, it's 8 volts divided by the current at that point, and here's current, and it is 5. But because this is volts, this needs to be in amps to give us ohms, and this is milliamps. So I'll do it up here. 5 milliamps, milli means thousandths, so it's 0.005 amps. Don't get caught out with that. 5 milliamps is 0.005, or you can do 5 times 10 to the minus 3, which means 5, and because it's minus, divide by 10 3 times, which is dividing by 1,000. So on the calculator, I'm going to do 8 divided by 5 times 10 to the minus 3. 1,600 ohms. Let's do it the other way using 8 over 0.005 amps. You'll get the same answer. 8 divided by 0.005. It's the same answer. There we go. So we've worked out that, and we've got our 5 marks for that. What did I really do? I drew a dot. I worked out a number across from the dot. I worked out a number under the dot. I changed that number by dividing it by 1,000, and then I did one over the other on a calculator. I didn't actually have to think hardly at all, and I've got 5 marks. There we go. But I'll continue next week and the week after, and what's really important is that you keep getting in touch and telling me what you want to hear and what you want me to go through. And also what's important is to read the stuff that I've put up and the stuff that Chris made and Clarice shared, the worked examples, and watch the videos. I've done loads of videos recently which are high mark questions, and they all help you get loads of marks early on and then gain confidence. So you need to practice and practice and practice, and you'll soon get them if you practice and make a note of the formulas that I've shared with you as well.